Hello again, my name is Panu and this is my channel for building this 50-meter liveaboard cruising sailboat right here in Finland. The boat is quite big and we are very beginning of the process here. So far I have built this shed, collecting all these tools you can see, and built that CNC router behind me there. And in the last video I finished this laminating table, and in this video we are going to use it for the first time by making a test piece number 3. The boat will be built with wood epoxy method, and for that I made this test piece last winter. I have never worked with epoxy like this before. And then I made this another piece which is part of the frame, and yeah, with this I learned quite a bit more. So the lamination itself works quite well, but there is a few issues I need to focus on to get these right at the first try. If you look at this end here, the quality of the lamination is quite good. But the problem is that these strips of wood are a bit too thick for bending in a form like this. And there is even tighter bends, like in this very first zero frame I have here. And the second problem is that the clamping down wasn't nearly enough in my test, so you can probably see there's quite a bit of gap between these pieces here. So the lamination is okay. I need to make thinner strips and develop the clamping method so that I can push down these pieces on the table very firmly. So I have this big jointer planer here, and I tested it for the first time a couple of nights ago, so let's take a look first what happened there. All right, this is the first time I tried this thing. I put this in here and adjusted the table height so it should take just a tiny bit of material when I push it through here. So yeah, let's check out what kind of horrible noise this thing keeps. All right, plug your ears. Oh, it turns in the wrong direction. Okay, yeah, I need to change some wiring. This is 3-phase motor and you change 2 wires and it should go all the way around. But it works! Woo! Alright, new try. Let's see. Yep, now it turns in the right direction. Let's try it. Yep, it works all right. The very first planed surface right here. It was quite undramatic. I think it will give a false feeling of safetiness. The blade is running just right there. If you push here or do something like that, your fingers is gone. All right, it works. Woohoo! Let's then try the thickness planer. Yeah, it definitely works. Works very well. Not a single complaint. This is really exciting. I have never had this kind of machine at my own disposal. Yeah! Then another test. This is maybe 4-5 millimeter thick piece. I try to make it 3 millimeter with this thing. Now this is 5. 4. Now it's a little bit over 3 millimeters. Okay, now this is 2.5 millimeter. It's almost like a veneer. This machine is so good. No problem whatsoever to make this thin of a material. Only problem, of course, is that there is a waste of maybe 70% when making it like this. So, I don't know. But yeah, you can definitely do very, very thin and flexible pieces with that. All right, test successful. As you saw, I can very much make these thin strips like this with this planer. This is maybe 2.5 millimeters thin and it bends quite well actually. But the problem is that when you make thin strips like these, you start with maybe a 5 to 7 millimeter thick pieces and then start to plane them and end up with maybe 2 to 3 millimeters. So you can quite easily calculate how much material is wasted as these shavings here. So that's not really an economical way to do these, although the quality is very, very good. And that's why I'm gonna build a drum sander, and I think that's gonna be completely different video. For this test I'm having here, I think I'm just gonna go with this planer. So this is the test piece number 3, and it is actually part of the frame number 0, which is the very first frame in the boat. Here will be the keel and the stem like this, and this has 2 pieces on top of each other right here. If you are not familiar with the method I'm gonna use, you can check the videos up there. These have been cut with the CNC, and from the previous test piece I have now put 2 of these dowels in each, so spacer pieces will be held firmly in there. And actually the first thing we're gonna need to do here is to make those spacers. I have already the program ready with the CNC to do those. But yeah, let's go and start that program to make those spacers, and then start to figure out the actual materials for the strips. So what you saw me doing there was to just clean up the surface. There was a bit of a burrs from the previous screws. And now I put double-sided tape to hold this place initially. And the first program I'm gonna run here is to make mounting holes for this piece, so I can screw it down and hold it in place when the actual pieces are coming off. So this is just a scrap piece of kind of glued board I found from the pile, and I'm gonna use it for these spacers. This is kind of the simplest method I have come with so far. If you have any suggestions, please comment down below. All right, here we go. These are the spacers between the two pieces here, and yeah, you have seen all this before. I just glue these as one piece, and then we can start figuring out the strips. But one thing you might notice, I just sanded these edges off and the tabs and stuff like that. I really need one additional tool to make this more efficiently, and that is a small hand router to route these rough edges, which may or may not be remaining from the CNC. It didn't go all the way through in every place, so the Z might be a little bit off as well. But yeah, these tabs and those are a bit annoying to get off with the sander, but one additional tool I need eventually anyway. Now these are done. I will do these off camera. But next few things I need for this test is, of course, those strips. We'll get back to those a little bit later. But one important thing are the clamps. And what I'm thinking, I'm going to develop these clamps I did for the last test. The idea of these was that they should be through the hole like that and then just screwed down, but the holding power down wasn't good enough. So what I'm thinking, I'm gonna do a longer version of these that have two holes, so I can put it over the whole thing and bolt it with two bolts. But that way I can put even pressure on this thing, and I think that's gonna work very well. Another kind of clamp I'm gonna do is a clamp on the side here. So one problem was that when bending these strips, and so many of them, the force to hold them down is enormous, and I don't have enough clamps, and it's a bit of a hassle to do all these things with the regular clamps. So I'm thinking of doing similar maybe to these, but maybe a little thicker clamps that go on the table like that, and they have another screw clamp that push the things on that way. So that's kind of one thing I need to do here. Now I have this amazing table, so I can basically do any kind of clamps that go into these holes. And this is such a thick board that it really doesn't mind that at all. Let's start with the bigger clamps. All right, the first prototype clamp is done. Seems to work well. Now I can just push these as hard as I need. I think I'm probably gonna do rest of them with the CNC because I have one. Bunch of these are now needed. Maybe they could be even longer in some places, but we'll see. Now when I have these clamps done, I started to figure out how should I make the additional side clamps to push things against these molds. And yeah, my first thought that I would do something like this, put the holes in it, and on these holes. Now I figure out, I think I really don't need to do that. And I can actually use these same bolts for these as well as for these. Just making this a little bit lower, I can put this against here and put the screw here and push against there and then put the downward clamps at the same bolt like this. Seems to be like a good idea, I think. So this is a bit too wide. It should be something like that and then put the bolt right over there. It could work. All right, the last job of the day is to mill some materials for the strips. I'm gonna plane them down a little bit to make the surface nice and then with the bandsaw to cut them in thin strips. Ouch. And before that, I'm gonna put them through the planer and straighten up one side and then cut them the precise width for the frame in this way. So there should be, yeah, 2 sets of strips coming from this board. Let's see what happens. All right, now I have a bunch of this stock milled, planed down and sawed to size. Now it's exactly same width as this spacer is thick, so it should be good. And now I need to saw it in the very thin strips with this bandsaw. But the problem, what I noticed last time I did this, was that it's very difficult to hold it tightly against this guide, so it tends to wobble a little bit and the blade does something as well. So I need some kind of a mechanism to push it against this guide, and I thought I could innovate something with a couple of these small rollers and some plywood. There is a actually hole in there. I can mount this in here and make some kind of a leverage with this plywood here to push it against that. Let's try to do that now. Here we have the system, fully working order. There's now 2 rollers, and when I pull here, it will hold the piece against the guide without me having put my fingers near the blade. I still have to put a spring from here to somewhere around here to make it automatic, so I can use 2 hands to manipulate the. But yeah, let's try it. right, I don't know if you could see from the footage, but the blade a little bit wobbles, so the result is not very smooth. But I think the method would be like cutting one, then planing it down on these both sawn surfaces, and then go it over again. That way the surface against the guide is always planed. Will create quite a bit of waste, although. But another thing is that this blade here is quite rough and big, so maybe I should change smaller and finer blade. This French works. It held the piece right against that guide very well. And by having the blade 4.5 about, it creates 4 millimeters of thickness for this piece. All right, let's try to plane this down and see what happens. Now it's planed from both sides, looks quite good. Sawn thickness was a bit too thin, so there is a bit of roughness on this other end of the piece. And now this is almost exactly 3 millimeters thick, yes. Most of it looks very good. There are some knots here that went off. That was kind of expected. But yeah, I will adjust the blade just a tiny bit thicker to prevent this from happening. I think this is too wasteful way to do a lot of these, but for this test purpose I will do it like this. All right, that's it, that's the process. All right, as you can see, they snapped quite easily. Yeah, of course, it depends how the grain is going and how much there's knots. These are sprues, so there's knots everywhere. These are now 4 millimeters, and it's a bit too thick for this radius here, which is actually the frame number 0, which is the very first frame, and this is the tightest corner in all the boat. So yeah, I think I have to plane these thinner in this case.
I'm thinking now of making this test lamination actually from some other frame than this, because this is so difficult to make with this scrap material I have now here. So yeah, I think I'm gonna ditch this and make the test from the frame number 17, which is the last frame, the very stern of the boat, and it has much more gentle curve, and this should work there just fine. But yeah, something to learn here. This has a radius roughly, would I say, 20 centimeters, which is quite tight for lamination like this. And yeah, these should be even thinner. But something about the waste ratio. The material I did for this purpose was 23 millimeters thick, and I got 3 slats from it. And these are now 4 millimeter slats. They are a bit too thick for this, but I think the 4 millimeter will go in the bigger radius just fine. So if you measure, the complete thickness of 3 of these pieces is now 13 millimeters, roughly. So 10 millimeters was wasted, which brings it to 56% of the material is actually used here. So the wasted percent is roughly 45. So almost half of the material goes into waste in this process alone. And of course you have to remember, I already planed them down quite a bit to get them straight and in the size. So yeah, it's way over 50, I think, the wastage percent. But I think this method that I used with the planer, this works quite well. I actually don't need to take that much off from the sawn pieces. It's like 1 millimeter or less to get the roughness out of these. So if I adjust the bandsaw blade just in the right position, I can make it pretty accurately and pretty efficiently. But I'm going to build the drum sander anyway, just to try it, and I think I'm gonna need it anyway in some point. And it's of course a fun project to do with the CNC. Let's now get back to the computer and make new mold for the test frame number 3 and ditch this one. It was a good practice. And this is Panu from the future. While editing this video, I realized it's coming way too long, so I will chop it right here and make the rest of it to the next episode. Stay tuned for that to see what's going on. And remember to subscribe and give me a like and comment down below if there's anything you suggest I do differently or stuff like that. And we'll see you hopefully soon. Bye.